Hello! In this figure we have an oblique triangle with side B of 22 units, side A of 16 units, and angle A of 42 degrees. We need to find angle B, angle C, and side C. This is the case when we are given two sides and an angle opposite one of them. So this is a side-side angle triangle, and it is also called the ambiguous case because it can result in one triangle, two triangles, or no triangle at all. When the side opposite of the given angle is less than the other given side, then we can either have two triangles or no triangle at all. So again, if A is less than B, then this can result in two triangles or no triangle. Now, one method of finding if the given information will result in two triangles or no triangle is to find the height that we can draw from point C. Then, if A is less than H, we will have no triangle, but if A is greater than H, we will have two triangles. So again, if A is less than H, we will have no triangle, but if A is greater than H, we will have two triangles. So then, we will start by finding H. For this, we will use this right triangle, and we will say that sine of angle A equals the opposite side H divided by hypotenuse B. So sine of angle A equals H over B. Then from here, H equals B times sine of angle A. Then H equals 22 times sine of 42 degrees, and H is approximately 14.7. So we just found H, and now we see that A is greater than H, and this means that the given information will result in two triangles. So let's see these two triangles in the figure. So we have angle A and side B, and this is the height. However, this side A can be closed to the right of the height or to the left of the height. And now we have two triangles. The first one is the triangle A, B sub 1, and C sub 1, and the second one A, B sub 2, and C sub 2. In the first triangle, B sub 1 is an acute angle, but in the second one, B sub 2 is an obtuse angle. Also, in the first figure, because this side is the same as this side, then here we have an isosceles triangle. This makes angle B equal to this angle. Then this angle is the angle B sub 2 in the second triangle. And if this angle is the angle B sub 1 in the first triangle, and it is equal to this one, then we can say that the angles B sub 2 and B sub 1 are supplementary. So I will make a note that the angles B sub 1 and B sub 2 are supplementary. And this means that their sum is 180 degrees. And now let's start by solving the first triangle. Here we will need to find angle B sub 1, angle C sub 1, and side C sub 1. We are given side A and angle A, and we also have side B, and we can use the law of sines to find angle B. And the law of sines is side A over sine of angle A equals side B over sine of angle B equals side C over sine of angle C. And to find the angle B sub 1, we need the first two ratios. And for this I need some space, so I will clear the first triangle. And I also moved the formula to the top. So to find angle B sub 1, we need A over sine of angle A equals B over sine of angle B sub 1. Then we will replace, and we will have 16 over sine of 42 degrees equals 22 over sine of B sub 1. Then we will use cross multiplying, and we will have 16 times sine of b sub 1 equals 22 sine of 42 degrees. Then sine of b sub 1 equals 22 sine of 42 degrees over 16. Then b sub 1 equals inverse sine of 22 sine of 42 degrees over 16. Then here we need the calculator in degree mode, and we will have that b sub 1 is approximately 66.9 degrees. Now, once we have the angle b sub 1, we can find the angle c sub 1 by subtracting these two angles from 180 degrees. So c sub 1 equals 180 degrees minus 42 degrees and minus 66.9 degrees. Then c sub 1 equals 71.1. And now, once we have the angle c sub 1, we can find side c sub 1. And again, we will use the law of sines. And because we need the side c sub 1, we will use the ratio c over sine of c, and then we can use one of these two ratios. And since side A and angle A was initially provided, I will use the first ratio and then this one. So we will use A over sine of angle A equals side c sub 1 over sine of angle c sub 1. Then we will replace and we will have 16 over sine of 42 degrees equals c sub 1 over sine of 71.1 degrees. Then using cross multiplying, we will have c sub 1 times sine of 42 degrees equals 16 times sine of 71.1. And if we divide both sides by sine of 42 degrees, we will have that c sub 1 equals 16 sine of 71.1 degrees over sine of 42 degrees. Then again we need the calculator in degree mode, and we will have that c sub 1 is approximately 22.6 units. So here we solve to the first triangle, and we have angle b sub 1, angle c sub 1, and side c sub 1. Now let's solve the second triangle. Here we still have the same side A and the same angle A, and we also have the same side B. However, angle b sub 2 is an obtuse angle. In the previous triangle, we saw that if we use the law of sines to find angle B, the calculator will give us an acute angle. So instead, to find angle b sub 2, we will use the fact that b sub 1 and b sub 2 are supplementary. So then, b sub 2 equals 180 degrees minus b sub 1. Then b sub 2 equals 180 degrees minus 66.9 degrees. Then b sub 2 will be equal to 113.1. Now we can find the angle c sub 2. So c sub 2 equals 180 degrees minus 42 and minus 113.1. Then c sub 2 will be equal to 24.9 degrees. And now what we have left is to find the side c sub 2. And for this we will use the law of sines. A over sine of angle A equals c sub 2 over sine of angle c sub 2. Then we will replace 16 over sine of 42 degrees equals c sub 2 over sine of 24.9. Then we will use cross multiplying, and we will have c sub 2 times sine of 42 degrees equals 16 times sine of 24.9 degrees. Then we will divide both sides by sine of 42 degrees. Then c sub 2 will be approximately 10.1 units. So here we have the dimensions of the first triangle and here of the second triangle. Thank you for watching.